Hello, today we're going to be talking about hypothesis testing and going over a brief basic introduction to this, as we will do more later on in statistics. So we have found standard deviation, and then we'll need that to compare some sample statistics with population statistics. And we're going to design some experiments and do some hypothesis testing. Again, some basic ones, but it works for now. So a 95% confidence interval can be found or estimated using the following formula. The confidence interval equals our x bar plus or minus 2 times s over the square root of n, where x bar is the mean, s is the standard deviation, and n is the size of the sample. Now we're going to be comparing this to the actual population. So remember, we're always consistently going ahead and not pulling the entire population. We're just pulling a sample. This is going to allow us to go ahead and test to see whether or not that value in the sample is good enough to represent the population. And we're going to do that at a 95% confidence level. Am I 95% sure that that will go ahead and happen? And so we're going to create an interval that we are 95% sure will be an acceptable interval. So let's go ahead and just show you how this works with the different numbers, and then we're going to do set up a tentative test to go ahead and show you how this would work. So just to find the confidence intervals, so say we have 400 commuters, and the mean, so x bar is 12.4 with a standard deviation s of 3.5. Determine the 95% confidence interval. So here's our formula. So into x bar, we're going to put that 12.4. The 2 is just part of it, times s, which is 3.5. And the square root of 400 will go in the denominator. Do that, plug those in. We get 12.4 plus or minus 3.5. Again, remember, plus or minus is one time plus, one time minus. So that's going to create our interval. So we're going to go from 12.05 to 12.75. And that's the value that we want our mu to be in, our population value. So it's going to be somewhere in there. We're 95% sure that it's somewhere in that value. So that's how we do a confidence interval. Now let's do that with some actual problems. So to do that, we are going to do these steps to do a hypothesis test. The first one was we're going to state the null hypothesis, h sub 0. And then the alternative hypothesis, we're not going to focus much on that. We're just going to deal with the h naught here. All right. Design the experiment, conduct the experiment. We're really not going to do that. We're just going to get the data from that. So step 2 and 3 are kind of not important right now. We're going to find that confidence interval like we just did. And then we're going to go ahead and look to see whether or not we can accept or reject the null hypothesis. All right. So here we go. An average grade point, the average grade point average in Algebra 2 at one high school was 2.6, with 2 being a C. So a little bit above a C, close to like a B minus. For a random sample of 34 students who worked part-time, the mean grade was 2.4, with a standard deviation of 0.6. See if this hypothesis of the average grade for the work of part-time is the same as the overall grade. So we're going to see whether or not these sample of students represent the overall population of everyone who takes Algebra 2. So our hypothesis, our h naught, is that our value is going to be 2.6. Again, don't worry about the value here. We're just going to ignore that. We're focusing on this value right here, that 2.6. We want to see if it's going to be that value, or if that value is going to be within our confidence interval. So typically we're going to design the experiment, and we're going to do all these different things, and we're going to conduct the experiment and collect the data. They already gave us the data. 34 students, x bar was 2.4, and the standard deviation was 0.6. So we're going to plug all of those things into that formula that we were given early on. So 2 with the s and the n, plug those in, and we get this value, 2.4 plus or minus 0.206. All right. So now we have to go ahead and 2.19 to 2.61. Now remember what we were trying to find. We go back, we have to say it equals 2.6. So is that 2.6 in my interval? Barely, but it is. 2.6 is in this interval. So we are going to accept it. So we reject the null hypothesis and we accept our hypothesis that yes, they're not, again, look at the way that they said they are not significantly different than the average. So they are average, they fit. It's a bad way of saying this because it's almost like a double negative here. But you're going to accept that that number was in there. All right, so let's try another one. Restaurants in one town were 3.6. So that's our value that we want it to be. See if this group fits. So 26 restaurants with an average rating of 3.2 and a standard deviation of 0.4. So we're going to state the hypothesis that it's going to be 3.6. Step 2 and 3 gives us those values. Again, we don't have to worry about that. Step 4, we're just plugging all those values in. For some reason, the formula didn't pop up here. I put it there. Oh, well. So it's 3.4 plus 0.16. So we get these values, 0.24 to 0.36. So we're looking at that 3.6. This is rejected. That 0.36 is definitely outside this range. So because it was rejected, that we can't say that these are fit in there. Oh, there it is. All right, so let's try another one. Accept or reject. So here's what we want. We want 56. Again, don't really worry about this one. So n equals 80, x bar is 55, and s is 5. Plugging it in, we get plus or minus 1.12. So add or subtract the 1.12, and our value, that 56, is definitely inside our interval, so we are accepting this. One more. Test this hypothesis. Now we have a 90. Are we looking to see if that 90? Here's the n, and oh, this is wrong. This should be 94. 94 plus or minus that that 0.85. I don't know why I put 75. That should be 94. And so this should be, when we get that 0.85, this is 93.15 to 94.85, which obviously is not that 90 value because it only goes down to 93. So we are going to reject it. That's a kind of a big mistake. That should be 94 there. All right. And that's all I have for you today.